If you've ever looked at a vector geometry question and felt like you were staring at a chaotic bowl of alphabet soup, you aren't alone. The letters and arrows look abstract, but we can replace that confusion with a clear, visual map of how these components actually work. We're going to break down the specific rules you need to navigate any vector plane and solve the pathfinding questions common in Edexcel IGCSE exams. Success in vector geometry comes from treating every problem as a physical journey across a two-dimensional plane. Let's build that map. In vector geometry, everything begins at a single fixed starting point. This is the origin, labeled with a capital O. Now let's establish a destination. We'll drop a point here at the coordinates 3, -2, and call it point A. To describe exactly where point A is relative to the origin, we draw a straight path connecting them. This is a position vector. We label it either with the capital letters OA with an arrow on top, or with a lowercase bold letter a. We can write this as a column vector. The top number, 3, dictates our movement along the horizontal x-axis, and the bottom number, -2, dictates our movement on the vertical y-axis. This establishes our first rule. Position vectors are always anchored to the origin. They take coordinate data and translate it into a specific movement pathway. Let's expand the map. We'll add a second location, point B, and give it its own position vector, lowercase bold b. This creates a logistical problem. What if you want to travel directly from point A to point B without starting back at the origin? This direct point-to-point journey is called a displacement vector. We write it as capital AB, with an arrow pointing from the start to the finish. It's important to distinguish these two. Position vectors relate a point back to the origin, while displacement vectors describe the path between two independent points. Because we often cannot measure this floating displacement vector directly, we use our anchored position vectors as a roadmap to find it. Think of the vectors you already have as established roads. To get from A to B, you must travel along the vector roads you've already defined. The first leg of our journey takes us from point A back to the origin. Since we are traveling against the arrow of our original position vector A, we have to reverse its sign. This path is -A. Now that we're at the origin, we can take the second leg of the journey. We travel up to point B, moving along our standard positive vector path, B. When we combine those two movements, we get a single mathematical formula. Our path from A to B is -A plus B. We can rearrange this formula for ease of calculation, writing it as B minus A. The consistent rule to remember is destination minus starting point. Any displacement vector is calculated by taking the destination's position vector and subtracting the starting point's position vector. Let's apply this to a standard column vector exam question. We have points P and Q with position vectors 4/1 and -2/5. We need to find the displacement vector PQ. Step 1 is defining the journey. Using our destination minus starting point rule, the path for PQ is position vector Q minus position vector P. Now we plug in the vectors. We set up our equation with the column vector for Q minus the column vector for P. Calculate the x values in the top row first. -2 minus 4 gives us -6. Next, calculate the y values in the bottom row. 5 minus 1 gives us 4. This gives us our final displacement vector for PQ, -6, 4. Strictly isolating your x and y calculations helps you avoid the common double negative errors that occur during stressful exams. To summarize, position vectors always relate a point back to the origin, while displacement vectors bridge the gap between two separate points. When you need to find that bridge, remember the pathway rule, destination minus starting point. Visualizing the grid and mapping these vector pathways provides a reliable foundation for navigating more complex exam diagrams.